Naming ionic compounds. So first, let's look at sodium. Sodium obtains a stable electron configuration by losing its valence electron. So if we get rid of this 3s1 electron, the next lowest energy level has a total of 8 valence electrons. So sodium is going to get to an octet by losing electrons. The next energy level has an octet. So by getting rid of that 3s1 electron, sodium is able to achieve an octet of valence electrons. So for each of the following, we want to determine if the atom will gain or lose electrons, how many electrons it will gain or lose, and the resulting charge of the ion. So go ahead and pause the video and work on this and return here when you are ready to check your work. So lithium is in the same column as sodium, meaning it has one valence electron. So it's going to lose that one valence electron and form a +2 charge. Beryllium has two valence electrons. So it's going to get to an octet by losing those two and forming a +2 charge. Boron has three valence electrons, so it's going to lose those three and form a +3 charge. And whenever we get to carbon, carbon has four valence electrons. So we're not really sure if carbon is going to gain or lose to get to an octet. So lithium, beryllium, boron, all of these elements form cations because their valence shells are pretty empty and they're going to lose electrons to get to that octet. My anions are going to gain. So nitrogen has 5 valence electrons. So to get to an octet, it's going to gain 3 more. So that would give nitrogen a -3 charge. Oxygen is going to gain 2 to get to an octet. It has 6 valence electrons, so its charge will be -2. And for fluorine and chlorine, they both have 7 valence electrons, so they're going to gain 1 more, forming a -1 charge in order to get to an octet. So the charges that an ion forms are known as oxidation states. So we want to write down the oxidation states for the groups that we know the oxidation state for. So everything in this first column is going to have an oxidation state of +1 because they lose 1 electron. Everything in this column is going to lose 2. Everything in boron's column is going to lose 3. Now, once we get to carbon's column, we're not sure if we're going to gain or lose electrons. So we're going to put a question mark there. We can also say the same thing for our transition metals. Transition metals are actually capable of forming different charges. So for example, iron can be +2 or it could be +3, depending on what compound we're dealing with. So we don't know what charge those are going to form. We just put a question mark there for now. Nitrogen's column is always going to be -3. Oxygen's column is -2. Fluorine's column is -1. And the last column here, our noble gases, those already have a full octet. So they're not going to form bonds. They're not going to form ionic bonds. They're not going to gain or lose electrons because they already have a full octet. That's why the noble gases tend to be very non-reactive. They're already stable as atoms because they already have a full octet. So for question 4, why is it difficult to assign an oxidation state to group 14? So go ahead and pause the video and think about this and return here when you are ready to check your work. So with oxygen's column, we're not sure if it's going to gain 4 or lose 4 valence electrons. So we're not sure what charge we're going to have for that column. So now we want to practice actually writing names and formulas here. So on your page, you have detailed directions that you can refer to. Here we're going to do sort of some abbreviated directions here. So first thing we want to do whenever we go from a name like magnesium acetate to its formula, we need to write out the cation and the anion. So I've got magnesium, that's going to be Mg, there's my cation, and acetate is a polyatomic ion. So there's the formula for acetate. So the next step here says to watch out for polyatomic ions. That would be acetate would be an example of that. You're not going to find polyatomic ions on the periodic table because these aren't individual atoms. They are many atoms that behave as a single ion. So you would refer to your polyatomic ion sheet for the names and formulas of these ions. Then we want to determine the charges, either using Roman numerals for transition metals or its position on the periodic table. So I know that magnesium is going to form a +2 charge because it is in the second column on the periodic table. It loses 2 electrons to get to an octet. So magnesium's +2. Acetate is a polyatomic ion with a charge of -1. So with an ionic compound, we always want to make sure that the overall charges are going to add up to 0. One quick way that we can do that is to crisscross applesauce. So I'm going to take this 2 and bring it down here. And I'm going to take this -1 and make it into a +1 and bring it down here. So what that does is it helps me figure out how many I need to achieve no charge overall. So I have 1 magnesium with a +2 charge, and I have 2 acetates with a -1 charge, so that gives me -2. So notice that around acetate, I have a parenthesis, and that's because I'm trying to say that there are 2 acetates. I don't want to confuse it for, something like this. So we're not trying to say C2H3O22. We're trying to say that we have C2H3O2 and there are 2 of them. All right, so let's take a look at the next one together. So the next one that I have here is calcium phosphate. So I'm going to start by writing out my ions. First, I have calcium. So that's a monatomic ion, just 1 atom. And then phosphate is a polyatomic ion. If you see something that ends with ate or ite, you automatically know that that's a polyatomic ion. So phosphate is PO4. That's going to be a polyatomic ion. Now we want to determine the charges on these ions. So calcium is in the second column, just like magnesium. So it's going to form a +2 charge to get to an octet. Phosphate is a polyatomic ion with a -3 charge. So remember, we want to make sure these charges add up to 0. Calcium is +2 and phosphate is -3. So the least common denominator there is going to be 6. So if we can aim to get +6 and -6, we should have a good formula. So I'm going to take this 2, move it down here. I'm going to take this 3 and move it down here. When I do that, I have 3 calciums that are each +2. So that gives me a total of +6. I also have 2 phosphates that are each -3. So that gives me -6. So my formula is Ca3PO4 2. And again, we want a Roman numeral around PO4 so that it doesn't look like PO42. We're trying to say that we have PO4 and there are 2 of them. Okay, next we have aluminum sulfide. So we want to determine what our cation and anion is. So aluminum is Al. Now we have sulfide. And one of the rules that you're going to see for naming ionic compounds is that the second element, if it's just a monatomic ion, we change it to end with "ide." So, for example, nitrogen becomes nitride, oxygen becomes oxide, sulfur becomes sulfide. So that's how I know that this is just S. So no polyatomic ions here. Note that we have only two elements, aluminum and sulfur. So we need to figure out charges. Aluminum is in the +3 column and sulfur is in the -2 column. So once again, we're aiming to get a total positive charge of +6. So if I crisscross these charges, I bring the 3 down and make the 2 positive and bring it down. That gives me 2 aluminums that are each +3. And I've got 3 sulfurs that are each -2. So both of those add up to +6 and -6. So my formula here would be Al2S3. Our next example is iron 3 oxide. So let's start by identifying our cation and our anion. So iron is Fe. Oxide used to be oxygen before we changed the ending to IDE. Now, iron is a transition metal, meaning that we don't know its charge from the periodic table. Instead, that's what this Roman numeral is telling you. So this Roman numeral is not telling you that there's 3 irons. It's telling you that the charge on the iron is +3. So iron here is +3. Oxide is in -2 in that column. So again, we're aiming for +6 and -6. So I can crisscross these charges. That gives me 2 irons that are each +3 and 3 oxides that are each -2. So again, that adds up to 0. So Fe2O3, this is actually rust. Okay, there's a couple more that I'd like for you to try on your own so that you can monitor your understanding. So go ahead and pause the video to finish up the last couple of naming to formulas that are in this section, and then return here when you're ready to check your work. So lead 2 sulfate. Lead is Pb, and sulfate, ending with Ate, is a polyatomic ion. This particular lead has a charge of +2. Sulfate has a charge of -2. So if I crisscross these charges, I end up with 2 and 2. So anytime that you have a situation like that, you want to simplify. So those 2's would simplify to 1's. And that makes sense because you need 1 lead, that's a +2 charge, for each sulfate, which is a -2 charge. Next we have vanadium 5-phosphate. So vanadium is V, and phosphate is a polyatomic ion, PO4. The charge on this particular vanadium is +5. So remember that those transition metals can have lots of different charges. Phosphate is -3. So it seems like our least common denominator here is going to be 15. So if I crisscross my charges here, I get 3 ions that are +5 and 5 ions that are -3. So when I add those together, I'm going to get +15 and -15. So that should always add up to 0. Again, I need a parenthesis around PO4 because I'm trying to say that there are 5 phosphates, not PO45. Copper 2 chloride. So copper is Cu. Chloride used to be chlorine. Now this particular copper has a +2 charge from its Roman numeral. Chloride, though, we can look it up on the periodic table, and it's always -1. So I'm going to need 2 chlorides for each copper, so I end up with +2 and -2 for my charges. All right, So now we want to practice going in the opposite direction. So when we go from a formula to a name, first we want to write out the name of the cation. If the cation is a transition metal, we need to kind of work backwards to figure out the charge and then write that in Roman numerals. The anion is going to change from ene to ide, so, nitrogen to nitride, chlorine to chloride, sulfur to sulfide. And if you have a polyatomic ion, you're just going to write whatever that name is. So, Na is sodium. And we already know that sodium is always +1 because of where it is on the periodic table. So I don't need a Roman numeral for sodium. Now chlorine, we would change the ending to chloride. So this would just be sodium chloride. Next up, we have Ca, which is calcium. We know the charge on calcium is always going to be +2, so we don't need any Roman numeral here. Next, we have OH. So OH is a polyatomic ion called hydroxide. There's only a couple polyatomic ions that end with "ide," and hydroxide is one of them. So this compound would just be calcium hydroxide. I don't need to do anything with that 2, because if I were to go in the opposite direction, I know calcium is +2 and hydroxide is -1. Therefore, I need 2 hydroxides. So calcium hydroxide is our name here. Next up, we have MgBr2. So Mg is going to be magnesium. We already know the charge of that because it's in the second column on the periodic table. So then we also have bromine. We change that to bromide. So this would be magnesium bromide. And again, I don't need to do anything with that 2, because if I were going from the formula, the name to the formula, I know magnesium's always +2, bromide is always -1, so I know I need 2 bromides for each magnesium. This one has iron in it, and iron is a transition metal that can have more than one possible charge. So I don't know what the charge on iron is, but I know that chlorine forms a -1 charge. And since there's 2 of them, that means that my total negative charge is -2. So then the positive charge has to be +2. And there's only 1 iron. So the charge of that 1 iron must be +2. So we have iron 2. Chlorine becomes chloride. So the name here would be iron 2 chloride. So remember that Roman numeral is telling you the charge on the iron. It is not telling you how many there are. Okay, go ahead and pause this video and take an opportunity to practice some of the questions that are in this section. So you're going to try the rest of the questions in this section and then return here whenever you are ready to check your work. So iron is a transition metal that we don't know the charge of, but I do know the charge on chloride is going to be -1. There's 3 of them, so that gives me a total negative charge of -3. So my positive charge has to be +3. There's only 1 iron, so the charge of that 1 iron would have to be +3. So this would be iron 3 chloride. Next, we have zinc. I don't know the charge of zinc, but I do know that the charge of hydroxide is -2. So my negative charge is -2. The positive charge must be +2. And there's only 1 zinc. So this would give us zinc 2 hydroxide. We have a polyatomic ion here. Next up, we have CO3N2. So CO is cobalt, and I don't know the charge of cobalt from its position because it's a transition metal. But I do know that nitrogen would have a -3 charge. And since there's two nitrogens, that gives me a total charge of -6. So that means that my positive charge has to be +6. Now notice that there are 3 cobalts. So each cobalt must be +2. So this would be cobalt 2, nitrogen becomes nitride. So cobalt 2 nitride.